Welcome, esteemed colleagues and nuclear enthusiasts. Today, we delve into one of the most significant and controversial events in the history of nuclear testing, the Castle Bravo detonation of 1954. As a leading expert in nuclear engineering, I feel compelled to shed light on this pivotal moment that forever changed our understanding of thermonuclear weapons and their far-reaching consequences. The sheer magnitude of this explosion was unprecedented and caught even the most experienced scientists off guard. One of the most immediate and alarming consequences was the extensive fallout that contaminated hundreds of kilometers beyond the designated test site. The radioactive debris was carried by winds far beyond the predicted fallout zone, affecting inhabited islands and vast stretches of the Pacific Ocean. In a twist of fate that would shock the world, a Japanese fishing boat, the Lucky Dragon 5, was caught in the fallout zone. The crew members of the Lucky Dragon 5 suffered from acute radiation sickness, with symptoms including nausea, headaches, burns, and bleeding gums. The unexpected yield was primarily due to the presence of lithium-7 in the fusion fuel. Scientists had incorrectly assumed that lithium-7 would be inert in the fusion reaction. Instead, it underwent nuclear transmutation into an isotope of tritium, which then fused with deuterium, significantly boosting the yield of the device. The Marshallese people, particularly those from the affected atolls, have suffered from elevated rates of cancer, birth defects, and other health issues linked to radiation exposure. The displacement of island communities and the loss of ancestral lands have had profound cultural and social impacts that continue to this day. Tragically, one crew member, Akichi Kuboyama, died 6 months later, his death attributed to complications from radiation exposure. Its unexpected yield, widespread fallout, and the irradiation of Japanese fishermen and local islanders shocked the world and changed our perception of nuclear weapons. As nuclear engineers and scientists, we must learn from this event, recognizing both the awesome power at our disposal and the tremendous responsibility that comes with it. The event played a role in shaping international agreements on nuclear testing, including the Partial Nuclear Test Ban Treaty of 1963, which prohibited atmospheric nuclear tests. While it represented a technological achievement in terms of yield, it also starkly illustrated the potential for unintended consequences in nuclear weapons development. The incident serves as a cautionary tale about the dangers of nuclear weapons and the importance of rigorous scientific understanding and ethical considerations in their development and testing. The 23 crew members aboard the vessel were exposed to significant levels of radiation, unaware of the invisible danger that surrounded them. The radioactive contamination affected marine life, coral reefs, and the delicate ecosystems of the Pacific Islands. It reminds us of the importance of caution, thorough research, and ethical considerations in scientific endeavors, especially those with the potential for such far-reaching consequences. As we move forward in the nuclear age, let us carry the lessons of Castle Bravo with us, striving for a future where the power of the atom is harnessed for the benefit of humanity, rather than its destruction. Studies conducted in the decades following the test have revealed persistent radioactive contamination in the soil, water, and local food chains. This long-term environmental impact serves as a stark reminder of the lasting effects of nuclear testing on our planet. This incident would become a diplomatic nightmare for the United States and a rallying point for anti-nuclear sentiment worldwide. The fireball from the detonation reached a diameter of 4.5 miles and left a crater 6,500 feet wide and 250 feet deep in the atoll S reef. The fallout, consisting of pulverized coral and other radioactive particles, fell like snow on nearby atolls and islands. The residents of Rongelap Atoll, located about 125 miles east of Bikini, were among the most severely affected. The incident forced a re-evaluation of testing protocols and safety measures, leading to more stringent controls and a greater emphasis on understanding the full range of potential outcomes in nuclear experiments. They were exposed to high levels of radiation, leading to acute radiation sickness and long-term health effects that would persist for generations. Castle Bravo, conducted by the United States on March 1, 1954, at Bikini Atoll in the Marshall Islands, was intended to be a routine test of a new thermonuclear device. However, what transpired that day was anything but routine. The explosion yielded a staggering 15 megatons of power, 3 times more than the expected 5 megatons. This miscalculation would prove to have dire consequences, making Castle Bravo the most disastrous nuclear test in U.S. history. To put this into perspective, the yield of Castle Bravo was approximately 1,000 times more powerful than the atomic bombs dropped on Hiroshima and Nagasaki during World War II. The unexpected power of the blast led to a series of catastrophic events that would have long-lasting implications. This widespread contamination had severe repercussions for both the environment and human populations in the region. But the impact of Castle Bravo extended far beyond the immediate vicinity of the test site. The irradiation of the Japanese fishermen struck a particularly sensitive chord in Japan, a nation still grappling with the aftermath of the atomic bombings less than a decade earlier. The Castle Bravo incident exposed the limitations of our understanding of thermonuclear weapons at the time. This miscalculation not only highlighted the unpredictable nature of nuclear weapons, but also raised serious questions about the ethics and safety of nuclear testing. The fallout from Castle Bravo had far-reaching environmental consequences. Moreover, the human cost of Castle Bravo extended beyond the immediate casualties. The Castle Bravo incident also had significant geopolitical ramifications. It intensified the global debate on nuclear weapons and testing, contributing to growing public opposition to nuclear proliferation. As we reflect on the Castle Bravo test, it's crucial to recognize its place in the broader context of the Cold War and the nuclear arms race. In conclusion, the Castle Bravo test of 1954 stands as a pivotal moment in nuclear history. The legacy of Castle Bravo continues to influence nuclear policy, environmental science, and international relations to this day.